Okay, cool. Hello, everyone. Welcome to today's Corundum developer meeting. Thanks for being able to take the time to tune in. All right. So today I've got just as usual, just a few status updates in terms of what I've been working on over the past couple of weeks. Now, one thing I will mention is that the research project at UCSD is kind of starting to ramp up a bit. So I've had to work more on, stuff running on top of Corundum instead of Corundum itself. So um if progress seems to have slowed down a little bit, that's kind of what's going on. So just a little bit of an FYI. All right, so status updates, summary. Most of this stuff is just carryover stuff. The main thing I've been working on is the CMAC wrapper and the AXI virtual FIFO that I'm putting together. And I guess I'll also just briefly talk about the kind of couple of bugs that we've been hammering away on. So that's more a question for MLE if they have any updates, but we'll get to that in a slide or two here. All right, so we've got the PCIe hard IP bug. Again, the model has been updated to support the workaround here using the tags, but the DMA engine needs to be updated, and then obviously the designs and whatnot to take advantage of that. So yeah, that's to do. I'll circle back to that some point relatively soon, hopefully. Then we have the FIFO memory inference issue related to the Intel devices. I know we talked about this a little bit before. I don't know if there's any updates from MLE on, in terms of getting this tracked down. Seems like what's been going on here is something in relation to the Quartus tools not using MLabs correctly in terms of, some of the FIFOs, and the result of this is effectively data corruption where it's playing out stale data, I think, when it's not supposed to do that. So it seems to have something to do with the merging of pipeline registers specifically into MLabs M20Ks. It's no problem on Xilinx devices, with the primitives there, it's no problem. So I'm not sure if there's been any progress on that. I haven't heard from MLE since last meeting. I don't know, Joachim, Ulrich, if you guys have anything to say about this particular issue, if you've done any more work on that front. Or we can circle back to that later if you don't have anything to add.
Well, I guess we can just say that we worked around it using M20Ks, and then yeah, that kind of works. We opened up an IPS case with Intel, and yeah, there is some interaction there. So let's see what they come up with.
Okay, did you guys put together like kind of a minimal design that exhibits this issue, or not yet?
We kind of said, okay, there is a public design available. Why not use this? So usually the minimal design thing comes from that you're not able to share the actual design, right? So you need to come up with an example, not sharing all the other stuff. But I think in this case that's okay, and it's not a build time that's too big.
Right. Well, I mean the minimal design also means you can usually run it through the simulator with the proper primitives and whatnot. You can do a post synthesis, post placement kind of simulation.
Yeah, that's right.
What's going on? Quartus, Corundum is not really set up to do a post synthesis kind of simulation. Maybe you could. Not sure. Haven't thought about how you might do something like that. But yeah, that's where minimal design could potentially come in, depending on what the problem is. Anyway, okay, so Intel has been informed, and I guess they haven't tracked down exactly what's going on yet on their end. So all right, I guess we'll see about that. Thanks for opening that case up, though. Hopefully they'll look into that, relatively quickly. And we'll have a resolution that actually allows the MLabs to be used. All right. So that's that. let's see, the CMAC wrapper that I mentioned last time, this one has now been integrated into all of the designs that use the CMACs. And I think I've tested that on all the boards just to make sure that everything works and all of the, you can communicate with all the GTs and whatnot as expected. I have not done any screwing around with changing much of the CMAC settings at this point. So stuff is connected, but it has not been, super, fully vetted and tested. Main thing is just to test to make sure that the data path works and you can actually send and receive data, close to line rate without, anything weird taking place. So the idea with this is basically do what I did with the 25 gig and 10 gig PHY modules, integrating that with the GTY or GTH GTY transceiver cores, where we have a wrapper module that kind of contains all of the interconnections and whatnot. Specifically to simplify all of the kind of management and configuration and whatnot of the GT cores, but also wrapping the PHYs just so everything's all nice and self-contained. That makes the integration, board level integration much simpler for these things. So the idea is to do the same thing for the CMAC. There were a number of things I had to figure out in terms of turning off CMAC placement constraints that are automatically generated in the cores and a couple other things. I thought I might be able to get away without CMAC placement constraints at all, but turns out you get some warnings from Vivado if you don't set those to specific locations. So I went ahead and added the placement constraints to the existing placement XDC files that I have. But that's not really a big deal. The main thing is to make sure that you actually have a different placement constraint for each CMAC instance without having to have a bunch of different CMAC cores, if you know what I mean. Right. So the status on this is that it's working in hardware. All the 100 gig designs have been updated with the new wrappers. But the to-do on this is to basically connect up a lot of these statistics related signals to take all the counters, packet counters, drop counters, things like that, and feed that into the statistics collection subsystem such that you can, monitor all of that good stuff from user space and from the driver. So I haven't done that yet because I kind of need to figure out how things are going to be laid out inside of the statistics collection subsystem. But yeah, that's looking pretty good so far, because with this current setup, you can now do things like run iScan on the GTs in 100 gig mode, and potentially we can change settings inside of the CMAC, such as enabling, disabling RSFEC. Let's see. Yeah, I guess I did have a small issue last time. Like, I thought I had everything working, but it turns out that I also had to implement a little watchdog, reset watchdog component to reset the receive logic, including the receive side of the CMAC and the GT, kind of similar to what the 10 gig and 25 gig PHYs need to do. I didn't realize you needed to do that because it wasn't detailed in the documentation, but it is in the standard CMAC wrapper. When you generate both the CMAC and the GT, it has a little reset watchdog that resets the receive side, I think every 750 milliseconds if it hasn't locked. So that's been implemented, and things seem to be working with that setup. All right, and the thing that I've been working on over the last couple of weeks here, the main other thing I've been working on is putting together an AXI virtual FIFO. And the idea behind this is to be able to buffer a large amount of packet data into DRAM. So in this case, there are kind of a few existing AXI virtual FIFOs out there. There's, Xilinx has one. I think there's at least one or two different open source ones, but they all have some pretty significant limitations in terms of the fact that they really only store, like, if you have an AXI stream interface hooked up, it really only stores the data. It doesn't even necessarily store like the tkeep sideband. So if you're putting packets in there, you kind of have to find a way to encode things. They usually don't store like the TID, TDES, T user fields, things like that. So that's kind of a bit of a limitation of the existing ones. So what I'm taking a look at is how to build an AXI virtual FIFO that can store all this metadata and framing information and whatnot, and do so efficiently enough that we can hit line rate 100 gig through this thing for all packet sizes. So 60 byte all the way up through, jumbo frames basically, and every size in between. So this includes corner cases like 65 bytes, which are, a little bit more difficult to handle on the AXI stream interface. That's kind of the idea. And I think this can be done across 2 DDR4 2400 channels or 2 HBM ports on the Xilinx devices, which is, so the DDR4 2400 I think is 512 bits at 300 megahertz versus the HBM ports are 256 bits at 450 megahertz. So that works out to a bit less, right? That's if you width convert that, that's equivalent to what, 512 bits at 225 megahertz. I think that's going to be enough if you merge 2 of those channels together. The main bottleneck in this case is the memory bandwidth. So we need some sort of a relatively efficient encoding scheme to encapsulate the framing and the sideband data such that you can actually spool all the packets into DRAM and then read them back out at full 100 gig line rate. So status of this in development, I'm chipping away at the implementation, but this will eventually go into the AXI library, and then you'll be able to use it from the application section for, if you got to build a really big FIFO for some reason, you'll be able to use that. So just figured I would toss that out there in case anybody else is interested in that kind of functionality. That's about the sum total of everything that I've been working on over the past couple of weeks here. Because, like I said, the research at UCSD is starting to pick up a little bit. So I'm working on, user logic and stuff that sits on top of Corundum more instead of Corundum itself. So yeah, I think that's about all I got in terms of updates. I don't want to go through all of the, carryover slides from last time. So what we can do now is open up the floor to discussion. I don't know if anybody has any questions or comments about anything, fire away. Nobody has any questions or comments about the slides, then, or anything else, then, as usual, we can turn it over to the folks at the MLE. I know they like to hold off to see if anybody else has any questions or comments.
Yeah, I guess it won't be much today. We perhaps a little bit of an update. I guess in the last meeting, we as in MLE left with a note that we might have another bug. In the meantime, it turned out this might be indeed, as I guess I mentioned it, software related.
Mm-hmm.
And that suspicion stays like that. The fact is, in the meantime, we have moved to an older kernel even than the one we are usually using. Also has to do with project requirements and so on. So we had to move to that kernel in the end anyway. And the positive thing is that this problem we are seeing is not hitting us with that older kernel. So for us, that possible bug mentioned last time is kind of on hold regarding any research on it.
What was the high level on that bug again, real quick?
Yeah, the high level is that at least when using in this case a 5.4 kernel or even a 5.15 kernel on our machines, and that might be specific. We are not using top notch here or the newest thing. That the simple performance of when using iPerf TCP peer-to-peer two machines, same boards, that there's apparently a problem on the receive side, a problem which which makes the physical line or the whole setup reach the 9 gigabits in our case, but not sustained, not all the time. There are phases where bandwidth is dropping down to more or less random values, phases with a lot of retries. And then after a while, the system makes it back to the 9 gigabit per second. And as we just went so far to say it has to do something with the receive path, since using only MQNIC for TX towards a standard NIC card, it does not show this behavior. And so we, at the moment, think it's a problem in the receive path, and it is definitely software related, or more or less CPU power related, I would say. Since I kind of have the feeling, I cannot prove it. It's just a feeling that it also depends on more or less CPU frequency. The faster the CPU, the less heavily the problem occurs. And we think the theory is might have to do something on the one hand with buffer recycling, or the missing buffer recycling, so to speak. We talked about that in the past. A feature available starting with 5.15, I think. And on the other hand, with possibly with missing IRQ coalescing and or limiting. Up until now, we did not employ or experiment with your recent addition of the IRQ limiter. That's still on the to-do list, so to say. Instead of doing research on that, we've moved back, also for other reasons, to this older kernel. And interestingly enough, or for us, it's a lucky hit. The problem kind of goes away when using that older kernel. So, and that's why I've said in the beginning, it's for us, it's kind of on hold for now. But yeah, well, in the end, I guess we have to circle around back to this issue and have a look and find out what the actual problem is.
Right. Okay. Yeah, that seems pretty straightforward. Basically, just performance issues on RX. But that's interesting that it seems to only be an issue on newer kernels, but not this older one. So this is a CentOS.
Very surprising,
right? Or
yeah,
well, not CentOS, but Rocky, something like that. Yeah.
Right. That's about the CentOS 8 standard kernel, which is
Red Hat or Red Hat derived, you know.
yeah, heavily patched 4.18 based.
Right.
Whatever they did something right in this case, obviously.
Yeah. I definitely think the memory management is potentially a potential issue there. Definitely suspicious. But yeah, until we do some sort of RX page recycling thing, there's probably not much that can be done about that. I guess potentially using memory pool kind of thing could help, but I think those APIs are relatively recent, right? They're not available on your older kernel.
Right. At least that's a problem for us. On the other hand, it, well, as I said, it kind of looks good with the old kernel anyway.
Right.
But it might. I mean, still, it's the kind of high CPU load with kind of not full blown traffic is obviously still there. I mean, as soon as we move to really full-blown traffic, 10 gigabit, then RP seems to move into polling territory, which makes sense. And in this case, we think that recycling, having the recycling feature would really benefit CPU load, or at least the strain on the allocator, deallocator.
Right. Yeah, that would make sense.
So that's kind of all more or less on our list for the future now. For the moment, we are kind of satisfied with the situation we have using that old kernel.
Gotcha. Okay. Yeah, I guess one other thing I should mention about the IRQ rate limiting stuff, I'm actually not sure, kind of in the current scheme of things, if that really has much impact on performance. Reason being that when you're in polling mode, which is what you should be doing under high load, it's not firing off any interrupts. And then it's only going to fire off, one interrupt per queue, which, if you have a lot of queues, I guess there could be multiple queues assigned to, each IRQ. It's only going to fire off one interrupt per queue, at a given time. So, and then you're kind of expected to go into polling mode if there's, multiple packets on that queue. So, it's not like it's going to cut the interrupt rate down by like 90% or something like that. It could help, but it's probably not going to make a, huge difference.
Yeah,
worth trying, but
from the experiments from the past, especially with not full 10 gigabit traffic, or not line rate on any whether it's 10 or 1 gigabit or something else, I guess if the system is not on line rate, it really makes a difference. I mean, it having IRQ, the IRQ is limited, just relieves the CPU or frees up CPU time for something else. So I just can remember our experiments from the past where we hit the MQNIC card with just 1 gigabit of traffic on 10 gigabit line. And the difference between, in this case, in this scenario, between MQNIC and standard NIC, in this case, it was Intel NIC, was substantial in terms of CPU load.
Interesting. Yeah. Well, that's probably something that could use some work at some point. Yeah, I guess the other thing that I've been working on, removing is all of the MMIO reads from the fast path, because that should, I think, help with things like CPU utilization, right? If the CPU is performing all of these MMIO reads, it's going to be sitting around waiting for the PCI Express, operation to complete before it can continue running. I'm not sure if the CPU is stalled during MMIO read or if you can actually do some kind of a context switch sort of thing. Not sure about that, but yeah, removing those I think will definitely help the CPU utilization. Now I'm not sure, gigabit versus, 10 gig, if you're running at 10% of line rate versus full line rate, if that's going to have much effect, but might need to do some experiments on that front.
Yeah, so perhaps last data point, perhaps interesting to know. we since you have included MSIX support, we again try to use the MQNIC card within a virtual machine. Back then, with just MSI, we had issues in virtual machines, and yeah, interestingly, it's the behavior is not the same as when using it on the native machine.
Interesting.
We don't know why. The effect is that we simply do not hit line rate. We see a lot of retries, kind of evenly distributed. That was just a quick try, but an impressive effect. And the take-home message was, yeah, it's not the same in a VM versus on a native machine. Why is the question that remains.
Interesting. And on the same machine, did you do a test, pulling an Intel NIC into the VM to see what happens?
Yeah.
And that works fine, presumably.
Yeah, the Intel NIC, it's the same, no matter if it's a native host or in the VM. Same VM settings, same amount of RAM for the VM, the same amount of CPUs. Interesting point here. No research done so far.
Right. Yeah. Definitely have to take a look at that, because that seems that doesn't make sense. Whenever something doesn't make sense, you gotta dig into it and try to figure out why. Yeah, I mean, it's entirely possible I'm doing something wrong, either in the driver or in the hardware, or both. So if we can figure that out, then we can sort that out. Just wondering, the VM setup that you guys are using for that, for PCIe pass-through, what's the setup? Is this just with KVM and libvirt or something, or?
Yeah, libvirt and driving KVM, and the pass-through mechanism, I guess there's only one on this level, which is using with Intel CPUs what is called VTD, I guess.
Okay.
In this case, no special kernel settings applied. There might be some rather standard Q35 based VM. I guess Qemu has two models, the older one, which is on the ancient 440 chipset, and the newer Q35 one. We can provide the settings here. They're basically the libvirt XML file, I guess.
Right. I just wasn't sure if you were using some other, virtual machine host software.
No.
I know there's a whole bunch of different ones, right?
Yeah.
I think the VirtualBox is a thing, but I don't know if VirtualBox supports that sort of thing. VMware. I know Microsoft has offerings as well, but yeah, okay. So you're just using KVM. All right. Well, I might take a look at that at some point, see if I can replicate that on my end. Put it on the gigantic to-do list, right?
Yeah.
Yeah, I guess the one thing that jumps out is that maybe it has something to do with the IOMMU, because that's a big difference between running bare metal and running with the virtual machine, is the address translation.
Might be the case.
So I'm not sure if that would be. So I'm not sure if that's something, say, to do with the page recycling, because they're always registering and deregistering memory regions. If you just keep them registered, that might be the difference right there.
Good question. Yeah.
I'm not sure if there's anything else in terms of what the hardware and the software that would be doing that could affect what the IOMMU is doing. Not sure. That's just the only thing that jumps out to me off the top of my head.
Yeah. No.
Yet again, page recycling.
I guess the first thing, as soon as we come back to that issue, is most likely to first of all move to a new kernel to have this page pool API available natively, and then apply our previously used small patch to support the page pool API in the MQNIC driver, and then try again and see what the difference is, how much recycling helps or does not help. The expectation is that at least at line rate, page recycling should help.
Yeah, definitely.
In a big way, I would say. On the other hand, we would expect that if we had IRQ coalescing, that at least at line rate won't help that much. Although perhaps another observation that puzzled me also, at line rate, I've looked at the MQNIC dump output regarding the RxQ, which was in use, and interestingly, I did saw that the queue has its ARM bit enabled, which means it's IRQ driven, which means that the NAPI told
the event queue or the RxQ?
The RxQ.
The RxQ, okay.
Or I think it's a completion queue, right?
Right, yeah. Right,
Which
the
has
RX
the
completion
ARM
queue,
bit.
yeah. It has the ARM bit set.
Yeah.
So it seems like NAPI is not actually running because that bit got set.
At least not all the time. I just wondered about it because from gut feeling, it was too much enabled and too less disabled.
Right.
Just looking at it while the traffic
I
was
guess the
flowing.
thing with NAPI polling is that it's not necessarily to get it running continuously, but to process packets in batches, right? It'll process whatever is in the queue, and then it will, re-enable interrupts and wait for something to happen. So if you see the ARM bit set, but it's not processing all the packets in the queue, there's a lot of stuff in the queue, then that's potentially a problem. Maybe we have an issue in the driver in terms of when it's reporting to NAPI that it's done. But if that bit is set and the queue is empty, well, it processed all the packets and it went to sleep. I mean, I guess there's also a difference of what line rate you're running at. 10G, the CPU can probably keep up without too much trouble, but at 100 gig, that's a different story.
Yeah.
So I guess definitely a bit of a head scratcher. I guess I'm not sure if we have any equivalent for looking at what the Intel NICs are doing, for example, to see if they're in polling mode all the time, or if they're dropping back out into interrupt driven with NAPI.
Yeah,
not sure.
I guess
under
one thing is to count interrupts, to look at proc interrupts before
that's
the test, after the test.
Definitely a simple thing to look at.
But I would expect that the NAPI developers also have instrumentation for that via Linux, via ftrace, perhaps trace points or something. I would be surprised if there's nothing to look at that.
There's probably something to look at. I think just interrupt counts are really simple.
Yeah.
All right. Well, is there anything else to discuss? Anyone else have any questions, comments, concerns? Crazy feature ideas? Nope. Going once, going twice. I guess not. All right. Well, I guess we'll we'll just I'll keep hammering away at stuff, and we'll meet up again in 2 weeks, right? I guess looks like December the 5th will be 2 weeks from today, right? Something like that. So, all right. I guess we'll go ahead and adjourn the developer meeting for today, if nobody has any objections to that. All right. All right. Well, see you guys later.
Thanks a lot,
See you in
and see you
winter.
guys.
See you.
Thanks. See you later.
Bye.
See ya.